In Java, working with Hibernate and JPA is not just about executing SQL queries. It is fundamentally about state management. Most developers think of an entity as simply a Java object that maps to a database table. But between your Java heap and your database lives a critical component, the persistence context. The persistence context acts as a first-level cache and a staging area. Every entity in your application exists in one of 4 distinct lifecycle states relative to this context. Whether Hibernate automatically saves your changes, ignores your updates, or throws a lazy initialization exception depends entirely on which state your object is in. This is why entity lifecycle is one of the most frequently tested topics in senior Java interviews. In this video, we will break down all 4 entity states: transient, managed, detached, and removed. We will look at visual state transitions, live code demonstrations with SQL logs, and the exact interview traps you must watch out for. Let's start with the transient state. When we simply create a new entity using the new keyword, it is in the transient state. Hibernate is not tracking this object yet, so there is no database row associated with it. Before we begin our demo, let us take a quick look at our entity setup. Here, we have our product class, mapped to the products table using standard JPA annotations, along with lombbox at getter and at setter. For the primary key, we are using a sequence-based identifier strategy with a dedicated sequence generator. This means Hibernate will assign the ID from the database sequence when the entity is managed. We also have a few basic fields to represent our item, including the product name, image URL, and price as a big decimal. Now that our entity model is ready, let us switch to our demo service and see the transient state in action. Let us look at this with a simple example. First, we instantiate a new product object and set its name and price. At this point, this is purely a standard Java object living in JVM heap memory. Hibernate does not know it exists yet, and it has zero connection to our database. Because it is not associated with the persistence context, it is in the transient state. Let us verify this in code. We print the product ID, and we call EntityManager.contains to check if Hibernate is tracking it. Let us run the program and inspect the console. As expected, the product ID is null, and contains returns false. Notice also that no SQL insert statement was executed. Because a transient entity is completely untracked, Hibernate has nothing to synchronize with the database. So, how do we tell Hibernate to start managing this entity? That is where the persist method comes in, when we call EntityManager.persist. Hibernate attach our instance to the persistence context, moving it from the transient state into the managed state, which is also commonly referred to as the persistent state. Let us verify what changed after calling persist. First, we check the product ID again, and second, we call EntityManager.contains. Look at the console output now. Hibernate contacted our database sequence and assigned a generated ID to our object. And contains now returns true. This confirms that our product is officially managed inside Hibernate's first-level cache. Now comes one of the most important concepts to understand for both real-world development and interviews. Let's see what happens when we update the price property from 65,000 to 60,000. Notice that we do not call any update method, and we do not call save or persist again. Now, let us run the application and inspect the console output. Look at that. Even without calling an update method, Hibernate automatically executed an SQL update statement. This mechanism is known as automatic dirty checking. When an entity enters the managed state, Hibernate keeps an internal snapshot of its property values in memory. When the transaction is ready to commit or flush, Hibernate compares the current state of the entity against that original snapshot. Because it detects that the price has changed, it automatically generates and executes the necessary SQL update statement. If an interviewer asks whether you need to explicitly call a repository update method after modifying a managed entity inside a transaction, the answer is no. Always remember this golden rule. Dirty checking only works on managed entities. If an entity is detached or transient, Hibernate will completely ignore your changes. Which brings us directly to our next topic, the detached state. An entity is detached when it represents a real row in the database, but Hibernate is no longer actively tracking it. Notice that after persisting, we call EntityManager.flush to synchronize our insert query with the database immediately. Now, let us detach our entity using EntityManager.detach. Next, let us modify the price to 50,000 while the product is detached. And now, let us check whether the entity is managed after detach by calling EntityManager.contains. Now, let us run the application and inspect the console output. As expected, contains returns false. And look closely at the SQL logs. Even though we changed the price to 50,000, Hibernate did not execute any SQL update statement when the transaction completed. Why did this happen? Because automatic dirty checking only monitors managed entities. Since our object is detached, Hibernate completely ignores any modifications we make to its fields. So, how do we save changes from a detached object back to the database? That is where the merge method comes in. Let us call EntityManager.merge and pass our detached product. Notice that merge returns a reference, which we will store in a variable named managedProduct. Now, let us verify 3 important checks. First, is our original product object managed? Second, is the returned managed product managed? And third, do both variables point to the exact same object in memory? Let us run the application and examine the output. Look at the console results. First, Hibernate executed a select query to load the entity, followed by an update statement to sync our modified price to 50,000. Now look at the Boolean outputs. Is the original entity managed? False. Is the merged entity managed? True. And are both instances the same object? False. Pay very close attention to this for technical interviews. Calling merge does not make your existing detached object managed. Instead, Hibernate creates or loads a managed instance, copies the detached state into it, and returns that new managed copy. Always make sure to use the returned reference if you want to perform further operations. That brings us to the fourth and final state, the removed state. The removed state represents an entity that is scheduled for deletion from the database. Let us call EntityManager.remove and pass our managed instance, managedProduct. Notice an important interview rule here. You can only pass a managed entity to the remove method. Passing a detached object will cause Hibernate to throw an illegal argument exception. Now, let us check if the entity is still managed, and inspect its ID. Let us run the application and view the console. As expected, contains returns false. Notice that the product ID is still present in memory, because the Java object still lives in the JVM heap. And look at the SQL logs. When the transaction commits, Hibernate executes an SQL delete query to remove the corresponding row from the products table. At this point, the record is permanently removed from the database, and our Java object will eventually be garbage collected once it goes out of scope. To quickly recap what we covered today, a transient entity is a brand new Java object living purely in memory. It is not tracked by Hibernate and has 0 footprint in the database. A managed, or persistent, entity is actively tracked inside the persistence context. It has a database ID, and any property modifications trigger automatic dirty checking without calling explicit update methods. Detached entity represents an existing database record, but Hibernate is no longer monitoring it. Modifying it will not trigger an SQL update unless you reattach its state using the merge method. And finally, a removed entity is a managed instance marked for deletion using remove, which schedules an SQL delete statement when the transaction commits. Mastering these 4 entity lifecycle states is essential for preventing silent database bugs and cracking your Java backend interviews. If you found this hands-on breakdown helpful, make sure to hit the like button, and subscribe to the channel for more deep dives into Spring Boot, Hibernate, and backend architecture. Let me know in the comments if you have any questions. Thanks for watching, and I will see you in the next video.